Hello, this video tutorial is put together to help you make measures of speaking fundamental frequency for your voice diagnostic experience. Make sure that you've reviewed the introductory videos so you know how to basically use the basic functions of the TF32 tool. And in order to be able to do this analysis, you need to open up one of two files. One is the file of the oral reading passage, and the other file, which you can do once you've done the analysis on the oral reading passage, is to use the picture description file. So what we're looking at here is a reading of the rainbow passage, and just to give you a quick heads up on how that sounds, I'm going to play some of that for you. When the sunlight strikes raindrops in the air, they act like a prism and form a rainbow. The rainbow is a division of white light into many beautiful colors. So you have an idea that this is just a healthy speaker reading this aloud at a normal rate and loudness. And we're going to use a F0 or a fundamental frequency extraction program that's part of TF32 in order to calculate the speaking fundamental frequency for this particular task. If you've already gone through the phonation frequency tutorial, then you'll know how this works. You go to the View Open and select the option called Pitch Trace, and you'll get a window that looks like this. What I'd like you to do is to select the Stats option. That's going to provide you with a statistical summary of the fundamental frequency estimates, and hit OK. What's happened now is we now have a new window below the sound pressure waveform, and this is the fundamental frequency plot. What has happened is the TF32 tool has used an algorithm to attempt to measure and estimate the fundamental frequency at equal intervals through the entire reading passage, so you end up with something that looks like what we call a fundamental frequency contour. So I'm just going to expand a little bit of this so you can see what we're talking about here. So what we're seeing here is the fundamental frequency estimates for the various words spoken during the utterance, or the reading passage. And a couple of things you want to do when you're doing this analysis is, the first thing is you want to make sure that the estimates look reasonable. And what I mean by reasonable is there's not a huge number of really dramatic changes in fundamental frequency levels jumping around all over the place. And with dysphonic voices that will often happen. What that's a function of is poor inability of the algorithm to accurately estimate fundamental frequency. And so the quality of the voice violates some of the assumptions that go into making those estimates. And in this case, we actually are seeing a pretty good representation. If I was to, again, expand another section here, expand, you can see that this is the fundamental frequency contour is moving around in a relatively consistent manner. You can see right at the ends of words or the beginning of words, sometimes you'll see these large jumps. And those are what I'm talking about. If there's just a few of those, we don't worry too much about it. But if they're really frequent, they're going to actually skew your results, and you may not be able to get accurate estimates. And so in those cases, you may just simply choose not to do the analysis, or claim that the analysis was not valid. Now if we go back to where we were, what you can do is you put a left cursor just prior to the beginning of the reading and a right cursor just to the end after the end of the reading. And what we see down in this window here at the very top are a number of statistical estimates. The first one is the mean fundamental frequency, and for me this is actually a recording of my voice. It's 96 Hertz. And then we have the minimum estimated fundamental frequency, 41 Hertz, which is probably due to some vocal fry. And the maximum value is 190 Hertz. The other measure that we want is the standard deviation of the fundamental frequency, which is 17.9 Hertz. So the two measures that we want are the mean value, 96, and the standard deviation, 17.9. We collect the mean and standard deviation of the speaking fundamental frequency for both the reading passage and the picture description. To do the picture description analysis, you just repeat this on the picture description waveform. Those two values will be taken and put into your assessment report. The standard deviation of the fundamental frequency typically gets converted to semitones, and that will be reviewed in another installment.